Hi, welcome to the Foundations of Data Equity. My name is Heather Krause, and I'm based in Toronto, Canada, and I'm the founder and chief scientist at We All Count, a project for equity in data science. And one of the things that I love about data, why I got into data as a data scientist and a mathematical statistician many, many decades ago, was that I loved the fact that data could help us solve social problems. And I really believed that data was objective. So, for example, what is the average classroom size in this school? There are 3 classrooms in this school, and the first classroom has 1 student, the second classroom has 3 students, and the third classroom has 5 students. What's the average classroom size in this school? You might say that the average classroom size is 3 students per class, and if you said that, you would be correct. However, you might also say that the average classroom size is 4 students per class. If you say that, you are also correct. How is it possible that something as simple as the average classroom size in a school with 3 classrooms could have 2 correct answers? The reason for that is that math is not objective. Data is not objective. Data has a worldview baked into it at all times. Both 3 and 4 are correct answers to what is the average classroom size. How is this possible? It depends on who you ask. It depends on whose worldview, whose lived experience you're embedding into the data. So, for example, if we ask the teachers in the classrooms, we get the more traditional answer, which is 3. So we go to teacher number 1 and we say, how many kids are in your classroom? And that teacher says 1. We go to teacher number 2 and say, how many students are in your classroom? That teacher says 3. Then we go to classroom number 3 and we ask the teacher, and that teacher says there's 5 students in my classroom. We add those numbers up, we divide by the 3 perspectives, and we get 9. We get 3, because 9 divided by 3 is 3. Most of you probably said that the average classroom size is 3. However, if what we're trying to understand is the lived experience of the children, not the lived experience of the teachers, what we need to do is actually ask the children, the students in the class, what their lived experience is. So we go to the first classroom and we ask the first student, how many students are in your classroom? That student says 1. We go into the second classroom. We ask the first student in the second classroom, how many students are in your classroom? That student looks around and says 3. Then we go to the second student in classroom number 2, and that student also says 3. Then we go to the third student in classroom number 3, and that student also says 3. You can see where we're going here. We go to the last classroom and we ask the first student, how many students are in your class? That student says 5. All the rest of those students also say 5 because they're accurately describing their lived experience. So we add up all the answers we get, just the same way that we did with the teachers. We get 35. We divide it by the 9 perspectives, and we get 4. So the average classroom size in this small school is either 3 students or 4 students, depending on whose lived experience you are prioritizing. This is what we mean when we say data is not objective. It always has somebody's lived experience, somebody's worldview, somebody's value systems embedded in it. The idea that data is objective is kind of a myth that needs to be examined as we use data more and more in the social sector, because in truth, data is not objective. Data is collected, analyzed, and communicated always from a worldview, from somebody's perspective. I really learned this when I was early in my career, several decades ago, doing a lot of work in rural Bangladesh. And I was spending a lot of time working in groups of women who were learning how to get dairy, more dairy production from their cows. And this is the way that we collected data with these women. And, coming from a North American grad school with a lot of professional education, this really opened my eyes to what data actually looks like on the ground. The idea that kind of raw data is maybe a spreadsheet that you can download from the internet is completely untrue. That is not raw data. That is data that has been extremely processed. This is much, much closer to what raw data is. And even this has all kinds of people's worldviews and opinions baked right into it. Also, as part of my experience working in Bangladesh, we did research to find out if a different project, not the dairy cow project, but a different project had helped increase the income in a community that was part of a international development project. This is the first chart we made, and we used this chart to say our project was a success. The people on the left are the control group. The people on the right are the project participants. And you can see that they both started at about the same place, and the project participants ended up with way, way more money by the end of our trial period. So it looks like they are a success. However, if you break the data out a little more carefully than just overall averages, we find out that if we make a line for each ethnic group, we find out that some ethnic groups benefited much, much more from the project than other ethnic groups. And this matters because not just from a mathematical point of view, but from a human point of view. Let's say you are in the ethnic group number 3, so that's the yellow line, and you're at a community meeting and you're getting some reports back from this project, and they're showing you this chart saying, hey, look, our project was a huge success. Most people, the average person in your community has way more money if they participated in the project. But you are from ethnic group number 3, and this clearly shows that the project did not work for ethnic group number 3. And you're looking around at this chart feeling like maybe something's wrong with you. You haven't had your money increase, but what isn't being communicated with the data is that the project only worked for certain types of people. The third really important thing to notice from this chart in terms of equity and data is the effect that this project had not on individuals, but on the income inequality gap in the community. You can see that in the control group, so the community without the project, at the end of our research period had a $24 gap between the most well-off ethnic group and the least well-off ethnic group. However, in the community with our project participants, they ended up with basically 3 times as big of an income inequality gap at the end of our project. So we can use data to say all kinds of things that are all true mathematically, but all have a worldview embedded into them. So we can use data to say our project was a great success. On average, people are earning way more money. We can also use our correct same data and different perspective to say we maybe need to re-examine our project because we tripled the income inequality gap. So both of those things are true, but both of those things have a different worldview or value system embedded into them. And this is why it's essential that when we're working with data, specifically data that is in relation to humans, people, that we take step-by-step processes to avoid the racism, sexism, homophobia, and just accidentally embedded values in our data and analysis. Data about people is not objective, but it can be transparent and intentional and purposeful. This can feel really, really overwhelming. So we've developed the data equity framework to help anybody that's working with data address equity issues systematically in each step of a data project. Some form of these steps is universal to all data projects. We've tried them out in corporate settings, we've tried them out in government settings, we've tried them out in small nonprofits, big international NGOs, and every single data project goes through these 7 steps: funding, motivation, project design, data collection and sourcing, analysis, interpretation, and communication and distribution. These are the 7 power points that you have to make choices to embed more equity and remove the racism and sexism and colonialism and the rest from your data project. The order of these steps reflects the typical data project process, but you can address them in any order. You don't have to start every time at the funding step. Lots and lots of people have already started working on their data project when they want to apply this framework. So they start at maybe data collection and work on analysis and interpretation. Many other people start at maybe only the communication. And then some people do start kind of at the quote unquote beginning with the funding. It's a linear process, but you don't have to start at the beginning. What you do in each step of the data equity framework will have equity impacts and interactions with all the other steps and with your project as a whole. The data equity framework works holistically and individually. So it's designed to support you wherever you are, to help you think systematically and strategically to embed equity into your data project. The first step is funding. No data project is cheap. Everybody has to get the money from somewhere, whether it's called budget allocation, grant applications, RFPs. There's all different names for it, but somebody is always funding your data project because data projects aren't cheap. One really cool resource that we recommend looking at in the funding step is the Mimi Onuoha Library of Missing Data Sets. She is a researcher and an artist based in Brooklyn, New York, but the Library of Missing Data Sets is online. And these are basically a card catalog of data sets that would exist, maybe should exist, if somebody was willing to fund them. So even at the very beginning of thinking about how to embed equity in data projects, it's really important to think, what data can we not even work with because nobody's willing to pay for collecting or analyzing this data? The second thing that we do in the funding section of the data equity framework is something called a funding web. And to do a funding web, you can get all the directions for free on our website, weallcount.com. I'll show that to you in a minute. But essentially, a funding web is a really simple tool you can use with all your stakeholders and team members and colleagues to understand the flow of power through your data project. It helps you see where the money is going, where the data is going, and where the influence is going. And the point of a funding web is not to point blame or accuse people of having bad power dynamics. It's to make it really easy to visualize and help you understand how you can improve the flow of power, the flow of data, money, and influence through your data project. When we work with stakeholders, we remove lines, we add lines. There's a whole process of kind of figuring out in this really simple visual way how to improve the flow of power through your data project. Step 2 of the 7 steps is motivation. Motivation is, why the heck are you doing this project? Every project has a purpose. And every project has an explicit purpose, which is stated usually in the grant application or in the funding proposal, in the project description. But every single project also has a great deal of hidden motivations. And it's not a problem that unstated goals and hidden motivations, implicit motivations exist. It's only a problem when these unstated goals and implicit motivations outweigh the core motivation, the real kind of why you're doing your project. So the best way to fix this is a simple 5-step process. Define your core motivation very clearly. Make sure your whole team understands it. Make sure that the core motivation is compatible with your equity goals. Second, define all your secondary goals. These are all the implicit motivations, both personal and team. Then use these, your core motivation and your secondary goals, to craft a motivation touchstone. And then finally, make sure that you share your motivation touchstone. Make sure it's transparent and that your team members can find it, that your stakeholders can find it, that anyone that wants to use your data or your data project can find your motivation touchstone and understand the purpose that shaped this data project. And when everything is much more in balance, you're in a much better position to actually achieve your specific core motivation with your equity and ethic goals baked into your project. Okay, step 3 is project design. Project design is where we move from thinking about the why and into the how. Project design is where we are now fully focused on operationalizing your data project. Project design is about conceiving your project or your data processes to be as good as they possibly can be. Don't worry, later on we're going to talk about how to keep it from getting as bad as it can be. There's 3 basic steps in a project design phase of the data equity framework. Step 1 is considering the blue sky. Step 2 is refining your research question. And step 3 is picking your methodology. So blue sky is basically a brainstorm of, okay, what are all the possible ways we could design this data project? Not just what our habits are, or not just what we did before, but what are actually the best possible, like the coolest way we could do this project. We could study up. Maybe instead of studying the least powerful people, maybe we could study the most powerful people. How are we sampling our geography? If we're doing a survey, are we doing a stratified sample based on geography that reflects the communities that we're hoping to serve? So for example, this is a map from nativeland.ca that is based on pre-colonial geography. So this is in the indigenous treaties and the indigenous language boundaries. This is a downloadable GIS map. I'm just showing you the one for North America because that's where I'm living, but they have them for many, many other parts of the world. These actually exist. There's no practical reason that if you're doing work with people that you couldn't use geographic boundaries that are suitable to their cultures. This is the kind of blue sky ideas that we come up with during the project design phase. Once you've had your blue sky brainstorm and you have all the possible structures and ideas and questions, the next step is to define your research question. Defining a research question is crucial in embedding equity into your data project. It's very important that you define your research question first and you choose your methodology second. This is a little bit backwards from what we sometimes learned in high school or college. Sometimes we're practicing a specific methodology, so we choose the methodology first and define the research question second. Data equity is essential that the research question gets defined first with as much input from as many diverse stakeholders as possible, and then we choose the methodology. Otherwise, methodological experts are getting way too much power in your data project. And I've seen many, many heartbreaking wrap-ups of data projects where we've spent lots and lots of money and lots of time using a very fancy methodology that does not answer the question that the people on the ground really needed an answer to. When you're crafting your data question, it's very important that you think about who are you asking to change? Who are you measuring change in during your research question? So how much improvement do we see in LGBTQ students feeling comfortable at their schools is a great research question to start with. However, it's really important to stop and take a minute and see who implicitly are we expecting to change in the way that we phrase this research question? In this research question, we are expecting LGBTQ students to change the way they feel as a result of our project. And there are many, many reasons why it might be very healthy and empowered for LGBTQ students not to change the way they feel. So there are equity and ethical problems in suggesting that we're going to measure the success of our project by changes in the way a marginalized or oppressed community feels, rather than measuring the success of our project by whether or not it created changes in the environment that it intended to create. Another one that we worked on with an international group of disaster relief nonprofits is what percent of our groups effectively connect with local governments at least once a month. This was one of the targets of this project. And it quickly became apparent once we analyzed it through an equity lens that many of these local governments were quite hostile to the groups that we were trying to support, and expecting them to effectively connect with the local governments at least once a month was actually not equitable and ethical. It was often not in their best interests to do that. Because this inequity got pointed out to us, we changed the research question from what percent of our groups effectively connect with the local government at least once a month to what percent of our groups make an empowered decision about their relationship with local governments at least once a month. So you can see how carefully defining your research question can lead to much more equity in what data you collect, how you measure success, and equity in all parts of your data project. And then it's only once we have selected our research question that we then move to choosing the methodology. So we have the start of a methodology matrix, which is a whole bunch of different types of methodologies, all statistically robust and all designed to answer very different types of research questions. So you can download and use this methodology chooser. It's certainly not exhaustive. There are lots of methodologies that exist that aren't yet included in the matrix. And please send us your comments. But this is why it's essential to choose your research question first and then choose your methodology. Phase 4 is what's often thought of as one of the most common parts of a data project, which is data collection and sourcing. This is where you get whatever data you are going to use in your project. Data collection is very social and relational activity, and most people already understand that it is deeply embedded with subjectivity. We could go on for hours and hours about embedding equity and ethics in data collection. However, in the short time we have today, I'm just going to talk about two things: social constructs and data biographies. Social constructs are also called demographics, and it's very important when you're collecting demographic data in a survey, in an intake form, using SMS, any way that you're collecting social construct data, you need to think about who is constructing the categories and whose definitions are we using. For example, one really common question is, who is the head of your household? And this is a very valid question. Lots of beneficiaries have different experiences based on who is the head of their household. However, how you define who is the head of a household is very complex and very deeply embedded with people's opinions about gender and power dynamics and economics and marriage. So there are many ways to take the very same configuration of people and define it as a male-headed household or a female-headed household, depending on your worldview. And this, of course, has a direct implication for how your data is collected, but more importantly, what results you find. So this is the way that your opinions, somebody's worldview, is being embedded not only into the data collection, but into the results themselves. Second thing is data biographies. Now, data biographies is a tool that we use as an antidote, as a correction to all of the power dynamics and opinions that are embedded into any data set. Data biographies, at the bare minimum, should accompany every data set you use. You should never use a data set without a complete data biography. And the data biography includes the when, the what, the who, the why, the how, and the where of the data set. It's kind of like metadata, if you've heard that word, but it's much, much more nuanced and in depth. And there are very, very good reasons. For example, rule number one for using only data that you aligns with your equity and your value systems is that you should never ever trust a variable name. Variable names do not describe what are in that data, and very, very frequently we come across data names or variable names that are very, very misleading. So just because something is called the rate of violence against women or the gender composition of a group does not mean that it actually contains that data. Rule number two is trust no one. Sometimes I hear, well, if you get your data from a data source that you trust, then you can trust that data. That is very, very bad advice. Not because that people are going to intentionally mislead you with their data, but there is often a lot of implicit assumptions as to what the data is measuring or how it's measuring that are not explicitly shared with external data partners. This is not to intentionally mislead. It's just because not everyone has realized yet how deeply you have to investigate the data sets that you're going to use. For example, here's just a simple example that if you there's lots of open data. Let's say we Google this. This is a school district in the United States, and we can see the count of students by race in this school district over time. We can see race is shown as white, Asian, two or more races, American, Indian, or Alaskan Native, Hawaiian Native, or Pacific Islander. And this is a very well-intentioned chart from a source that probably people would say that they trust. However, there is no way in this data visualization to find out how these students were determined to be of what race. And there are lots of ways in the United States that this is determined. Sometimes it's self-identity. Did they ask the students what race they were? Sometimes it's parental identity. Did they ask the parents what race the student was? Did some administrator look visually at people and decide what race they were? There are so many ways to assign a person in the United States a race that if you can't tell, looking at a data set or a chart, how they assigned the race to individuals, you should not use that data because it's very, very fraught with people's opinions about race. There are lots of good organizations that are working on ways to embed a data biography in your data sets. These are all fairly technical approaches. You need to be able to program right now to access any of these. So we have a very simple downloadable Excel sheet for data biographies that I'm happy to share with you. Again, at weallcount.com. It's free. You can just download it. There's examples and a growing library because most of the people we work with don't program and don't know how to use R or Python, but do know how to use Excel. So step 5 of the 7 steps is analysis. So now that you have your data and you have your project design, what are you going to do with it? There are 2 key things to look at in terms of how to embed data equity into your data analysis. The first is the denominator. The second is the elements of a model. The denominator we've already talked about, that is in the average classroom size. So who is the denominator in that average classroom size example from the beginning of this workshop will tell you whose worldview is being embedded. If the teacher's point of view is the denominator, the teachers are in the position of power, are centered in that data analysis. If the student's point of view is the denominator, then the students are embedded in that analysis. So if you are working with data and you want to embed equity, pay attention to the denominator. Second thing is paying attention to the elements of a model. Statistical models are growing in popularity in the social sector and in the mission-driven sector. And yet they're pretty complicated, and they are never, ever objective. What to include or not include in a model is directly reflective of your worldview. We're going to go very quickly through this, but we can spend more time later. Essentially, the thing that we want to understand in a social science model is the dependent variable. And the thing that we can usually control, like our project or our treatment or our policy, is the independent variable. And yet a model that wants to find out how did the independent variable, our project, affect the dependent variable, the outcome that we care about, that model usually has to have lots and lots of other variables in it in order to make it accurate. And how we choose what other variables to include in that model is totally an equity issue. There's no mathematical way to know what variables need to be in that model and how they should be in that model. It's totally an equity issue. Imagine we're working on a project that's trying to improve dairy production for female farmers. The agricultural training sessions are independent variables, and the amount of milk produced is our dependent variable. So that's our basic model. And we're trying to find out, did our trainings increase the amount of milk produced? And one of the other variables that we know we need to include in the model is the amount of time spent, because the amount of time spent working on dairy is an important thing to control for, to include in our model, to help us see, did our agricultural trainings truly make a difference? So the first time we included time spent in our model, we included it as a confounder. A confounder in a model is a typically called a control variable. So did our agricultural training affect the amount of milk produced, controlling for the amount of time spent on dairy? And the results from that model is yes, it did. It looked like milk production nearly doubled when we used time as a confounding or a control variable. However, when we went and talked to the women themselves who were in our agricultural project, it turned out that they did not think that our project was a success, and that they were exhausted. They said to implement all the recommendations in the training, they were working many, many, many more hours than they were accustomed to working. From the farmer's perspective, time spent should not have been included in the model as a confounder or a control variable, but instead needed to be included as a mediator, where it's kind of part of the causal path. So here, when we included time spent as a mediator in our model, instead of a confounder in our model, we allowed the amount of work that women did with dairy to vary within the model rather than holding it steady within the model. We found out that the agricultural training produced only the same amount of milk as before. So, sixth step of the 7 steps is interpretation. Now, interpretation sometimes doesn't even seem like it is a step, but the interpretation of quantitative output, or the interpretation of the results of an analysis, are another key place where we embed our ideas, our attitudes, and our opinions, taking something that might be objective and adding a worldview to it. For example, there's a thing called a compass algorithm that is used in some jurisdictions to give you a score that predicts how likely it is that a person will reoffend. And this score has been shown to give lower numbers to people with darker skin. And there is a lot of controversy around, is this algorithm fair? How does this algorithm work? And that's a very important conversation. However, one thing to do is to simply look at the interpretation, step 6 of the 7 steps. The interpretation presented as Compass gives you a score that predicts how likely it is that this person will reoffend is, of course, not an accurate interpretation of the number that the Compass algorithm gives you. The correct interpretation is that Compass gives you a score that predicts how likely it is that this person might be in contact with the police again, be arrested by those police, and not have the money for immediate bail release. So, by carefully examining your interpretation for equity and ethics issues, you get to a whole different conversation that's different and more immediately applicable to your data project. Every result stage has an interpretation stage. The results are the actual numbers that come out of your data analysis. And then the interpretation is where you put narrative and meaning around those results. So it's really important to remember that you are, in fact, doing that. A human brain is doing that. Our very last step of our 7 steps is communication and distribution. Now, there's a lot written in the world about data viz, so we're not going to go into data viz very much. But we are going to say, number 1, don't trip at the finish line. Don't put a lot of work embedding equity into your data project all through the previous 6 steps, and then just kind of throw together a default graph. Also, be aware that different goals require different solutions. It's really important that you remember that you need to choose specific audiences and prioritize specific types of people when you're communicating your data results. A report that's designed for everyone, quote unquote, is actually not. It's designed for your default settings, which is definitely not everyone. And then thirdly, this is part of the science of data science. So test it. Test your data viz and your communication products to see if they are effectively reaching the people you're trying to reach. We have 3 specific checklists that focus on equitable distribution. And they are the content checklist, the medium checklist, and the access checklist. And the way that you prioritize these 3 elements of your communication together hits the sweet spot for your intended audience so that your results can actually be used, understood, and interacted with by the intended audience, which is essential for equity. Content is what you include in your communication and how you choose to say it. The medium is what form your communication takes, like the difference between a paper, an animated video, and a searchable database. And access is how easy it is for your audience to get in touch or communicate with your reports, and how easy it is for them to understand. We have checklists that you can use for each one of these. And when you use the checklist, you need to think about who your intended audience is. So in the content checklist, when you're choosing your subject, your language, your length, your depth, your tone, are you prioritizing maybe your funder, like a foundation? Or are you prioritizing maybe the city residents who have actually contributed the data, without which your data project would not exist? It's very easy to think you're designing your content for everyone. But if you go through the checklist, you'll see that, for example, large foundations and city residents have very different needs around content, very different needs around medium, and very different needs around access. And that you will always be prioritizing someone. So allows you to make an equity choice in your data project and prioritize the most equitable audience rather than maybe the most powerful audience or the most wealthy audience. We'll touch on data viz just for a minute to say that you need to ditch this kind of dogmatic data visualization best practices for an adaptive user-oriented system. What we think of as data viz best practices are actually not culturally universal. Most human cognition or data viz studies that have been published in journals only use respondents from North America and Western Europe, and even at that, mostly use university students in North America and Western Europe. So what we call data viz practices are actually practices that work best for people who've already been trained to think and see in a certain way. So don't take those at face value. Actually design your data viz and test it with your audience, with your community, with people who think and see the way that your stakeholders think and see. I'll leave you last with just an example of a data viz change that we've made here at We All Count. And that is a very common data viz that's used in textbooks around the world to demonstrate the difference between equity and equality. And this is the first picture in most textbooks. There's three people looking at a fence, and this is equality. Equality is we give each of these people a box to stand on. That's not great because the person who could already see over the fence can still see over the fence, and the person who's really short still cannot see over the fence. So this is how supporting through equality doesn't usually achieve the goal that we're setting out to achieve. This is how the textbooks like to see equity. Instead of giving everybody one box, people are given boxes according to their needs. So the tallest person doesn't get a box, but the shortest person gets two boxes. And in the end, everyone can see over the fence. It's very well intentioned, but the data viz here has very deep ethical and equitable problems. First of all, I don't like the fact that the size of a person, the inherent value or inherent way that somebody was born is being used to signify their potential, as if the causes of human potential are inborn, that you're born with more or less potential. Secondly, don't love the fact that the first viz gives the idea that we're all dealing with the same barriers. We are not all dealing with the same barriers, and our ability to achieve that is not something inherent to us. We are basically all born with very similar potentials and are facing very different structural barriers and standing on very different types of ground. This is the goal, not people still facing structural barriers and standing on boxes that somebody gave them from the outside. This is the goal, where we've actually taken down the barriers, and the people that all have the same potential, are inherently the same, are standing on solid ground, able to be self-empowered and actualizing their own potential. So as we broke this visualization down and looked with intention at each element, we see the equity issues that we hadn't even thought of after decades and decades of using this example in textbooks. And that's the We All Count philosophy in a nutshell. That's why we use the data equity framework. It allows you to break down your project into steps and use a system to check for equity issues and fix them at all 7 steps of your data process. And we have lots of these tools for free online on our website. And our website is weallcount.com. You can see it right there, weallcount.com. And if you want to get in touch with me, you can reach me at heather@idatassist.com or on Twitter at datasys. We All Count has a free weekly newsletter that'll give you all kinds of new tools, book recommendations, help get you connected to the whole community of people that are working on equity and data, and give you all kinds of learning and sharing opportunities. So thank you very much, and I'll look forward to talking to you soon.